Yeah, welcome to this natural language processing session 2. In the earlier session, we have seen about the approaches to the basics of NLP. What does it means by? What are the core applications of NLP? Next, what are the language basics of NLP? Called as morphemes, phenomes, context, semantics. What are the challenges that come across with NLP? Now, in this session, we'll be discussing about the approaches to NLP and the basic steps required to perform text pre-processing with some real-time examples. As I mentioned, we'll be discussing about the approaches. Next, in the approaches, what is the difference between the classical NLP and how the deep learning is being involved in the NLP application? Next, we'll be coming across with the basic steps to perform text pre-processing with some real-time scenario. Next, we'll be discussing about the pipeline activity. Once we are done with the text pre-processing, then we'll cover about the NLP pipeline in detail. This is how the flow for this session comes across. As we have mentioned in the earlier session, there are some basic approaches to perform NLP called as heuristic-based approach, machine learning NLP, deep learning NLP, as well as we also have with the combination of pre-trained or transformer-based models. Next, hybrid, where we can combine some part of the ML part and as well as with the DL. In the heuristic, we are supposed to use or define some rule base, write some regular expressions, do some pattern matching, do some searching kind in this methodology. Coming to the machine learning, we are supposed to use Navy-based classifiers, support vector, decision tree, and perform some basic classification in terms of true or false, in terms of false positive, false comment or positive comment. Likewise, whether it is a spam or not a spam, that basic classification is done through machine learning approach. Next comes with the deep learning, where we are using transformers, recurrent neural networks, and use of the convolution neural networks with the help of neural networks, where all the word embeddings are being paraphrased and mapped to these embeddings, and then use with the help of transformers, we can do the analysis and perform the prediction in an easy way. If in order to do the pattern matching, in order to do the regular expression kind or a traditional basic NLP model processing, it is enough to use heuristic based approach and machine learning. Until and unless our data samples, our data models are big enough or having involved with multi-model data sets, or where we have more number of data samples, then we can go for deep learning and transformers, LLMs and all. So in the rule-based approach, you have one small scenario with the spam detection here we can see. Whereas in the machine learning approach, we are doing some in-depth analysis, sentiment analysis based on, here it is just the classification, yes or no, whether it is spam or not, whether you are doing here sentiment analysis. Whereas in the deep learning model, you are doing the context analysis, and next we are also in a mapping with a higher performance way. So in the transformers and all, we are seeing the state of art accuracy, and we are trying to achieve some less load onto the models and all. So we can divide the task, make use of some open APIs, and then do this, make use of the pre-trained models called as Google BERT models or transformers, and then make use of this Hugging Face transformers and all, and then make our customized model to be run on our machine system. Next, in the hybrid approach, it is balanced, it is reliable, and then we can make it compatible. So based on the accuracy, based on the complexity level and all, in order to implement the deep learning models, it becomes tiresome, it becomes complex as the model as the input data samples get increased. So till now we have seen the basic approaches. There is some difference between a classical NLP models that make use of the machine learning and the heuristics, and also with the deep learning. In classical NLP, as we are seeing here, the process of pre-processing text like tokenization, stemming, normalization, stop word removal, right, feature extraction, modeling, all these are being done step by step exclusively in classical NLP, and then it is being mapped to perform any of the approved tasks as sentiment analysis, classification, or entity extraction, or topic modeling, or whatever. But in deep learning, we are using the dense embedding process where the word embeddings are directly mapped to one or more word embedding models, and then with the number of hidden layers and all, we are able to process these final outcome in terms of class labels, or in terms of entities, or in terms of tokenizations or summarization context. In the deep learning, this is being done with the use of dense embeddings, we call. Here it is being done one after the other exclusively. After the pre-processing step, next comes the modeling, and next comes the processing, and then final prediction of the results. So in the deep learning, this is how the strategy is. But the concern comes, when are we going to use this deep learning? So when there is a requirement that we are having more number of huge density of data samples, textual samples we have in terms of audio, video, and it is in multilingual form, then we would like to use these deep learning models for our analysis. Still, there is a concern on deep learning approach for some reasons, for the following listed reasons here as overfitting. The model may get sometimes into overfit or may not perform properly for a small set of data. When I am supposed to do the reviews of a college which is having some 500 or 300 people, maybe I don't require to go for the deep learning model. But in case if I want to do the reviews analysis of the vote or the politics and all, which is being done, publicized in one day and all, then I would like to go for the deep learning. So the deep learning model may not appropriately perform well when there is a small data set. So you'll be having an issue of an overfitting. Similarly, we can also come across some kinds of few shot learning, or there may also be a problem of synthetic data generation in terms of text with the deep learning model, because the deep learning models require lots of huge variety of the dense data samples. Just by having a cluster or by having an input of 30 or 40 or 500 or 600 may not be sufficient. We need to generate more synthetic data. So that becomes challenging when we are using the deep learning for NLP. Similarly, maybe NLP models may not be very specific in trying to differentiate between the domain specific. The terms which are being used in medical and legal may not be differentiated well by use of these things. Here we can see the medical information versus here the football terminology where the user is using. So there are the terms which differ, their context, their meaning, their purpose may change when I'm talking about the glucose level, where the person is involved in the medical history, and also the person who is involved in sports and some legal activities or health concerns. So likewise, there is some gap where I can't do the proper domain adoption by using the deep learning through the NLP. Next is interpreting the models. There is some gap in when you are running the problems. There are some bias issues. Maybe some sentences may not be meaningfully understandable by the NLP models. Why do you think this is funny? So this image may not be understandable, may not be interpretable and all. Some common sense issues may come across. Lack of reasoning, because NLP models, we need to reason out the basic understanding and basic reasoning. Cat sat on a mat, cat chases a mouse, such I went to market. Why is the person need for you to go to market? Maybe I might have some other work, I need to purchase some things, I need to do some shopping kind. So there is some kind of that reasoning gap which may not be interpretable when we are going towards the deep learning approach. Next, obviously, it becomes costly when we are going to use this deep learning models. So when we are having a limited kind of a data samples, when we are very clear enough what is our strategy in terms of stemming or topic modeling, or our intention is to do the language translation, or our intention is to do the language modeling and all, then it is suggestible to go for ML and the heuristic based approach. So till now, we have seen the applications, the core task of NLP. Next, we have seen the language basics in terms of the building blocks. Yes. Next, we have seen the approaches. Next, we have seen the comparison of, and also the difference between the classical approach and the deep learning approach. Now, we will be moving little bit into the technical activity of NLP, starting with the basic pre-processing steps which are involved in performing an NLP model. Initially, before we try to do any text pre-processing and all, the first task is we have to ensure that the input textual sentences or the input textual content, whatever we are wanted to do the analyze, should be away from all some unnecessary content. So that process of removing, the strategy of making the data content available for us to run the model, that strategy we call it as text pre-processing. So now in this session, we will be seeing in detail about the text pre-processing steps. In that basic steps, we will be covering about normalization, stemming, stop word removal, lemmatization, and tokenization. Suppose I have taken a very brief example as an input sentence. We are discussing about NLP introduction in knowledge sharing sessions of this. So this is my input sentence. For this, how does the normalization take? So the first task is where we need to keep it in one case, whether it is in uppercase or in lowercase. Here generally we will be converting the given sentences into lowercase form. So here the output for our sentence will be the capital T being sorted out, the capital V, the comma is being removed. Next we have here the NLP, which is in the capital form. Next I, next the K, the S, all will be filtered out in the normalization as this output. Today here we could see where we are not having any full stops or any capitals, or we are not finding any double quotations and all. Now this is an filtered text content which is normalized form, away from punctuation marks, away from special characters, and away from the capital case. The next steps comes under tokenization. What is tokenization? Tokenization is a process of breaking the given sentence or breaking the given text into smaller individual units, which is generally followed or separated by the spaces. Now in this sentence, I can say this is one token, is one token, the is one token, process is one token. So in order to perform the tokenization, we have to ensure that our given input text is in a normalized form. So in the above slide, we have seen that our given input text is free from all these things, and it is a normalized output. So for that, even in this example, see natural language processing. So you have natural as one token, language as one token, processing as one token. So those tokens can be the words, can be sentences, can be subwords, depending upon how we are supposed to perform this tokenization. In this example, for our example, if you could see, today we are discussing about for this input sentence, the tokens are like this. One is today is one token. Even if we are considering just giving the direct this as my input text, then this is the output. Suppose if I give my normalized text, maybe the output may differ. That's what I mentioned, that this tokenization depends upon what kind of input we are giving. In this input, here I have considered the input which is not free from any double quotations or comma and all. I have taken the raw text, the raw given input statement as it is. So in this, you are having the tokens which are being split as double quotation as one token, R as one token, discussing as one token, about, sharing. Likewise, we are having some 6 to 7 tokens from this given input text. Okay, so we have seen what is normalization, we have seen what is tokenization. The next is stop word removal. How? What is the stop word removal? Is the process which is used to remove some unnecessary words which does not impact the usage or the purpose of the usefulness of the sentence. In this case, maybe comma, maybe fillers, maybe space, maybe some prepositions, some kinds can be removed. We have some libraries in NLP, in NLTK, and Spacey, in TextBlob, Genism for all to perform this stop word removal. You also have some standard algorithms called as Sparta, Stemmer and all to perform this task. So in our given text, we are removing the words called as we, are, about, in and all. These words can also be removed from this given. So in the given input text, okay, so these are our tokens. Today discussing NLP introduction, knowledge sharing, which is being away from these stop word removals. Actually, my given statement is we are discussing about NLP introduction in knowledge sharing session. So we has been removed, are has been removed, about has been removed, and in has been removed. Okay. Next is about stemming and lemmatization. Stemming and lemmatization are two important NLP techniques which are used, which forms a very good base for pre-processing. Stemming focuses on removing the prefix or suffix of a word. Suppose if I call it the word as suffix in this, maybe the last may be removed. If I say call as singing, then ing form will be removed. I will be left with sing. Okay, lemmatization also works similarly, but lemmatization gives a more precise and base root form for the given word. We will see in this next slide the example. Please have an attention here. See, change. In the stemming, change, changing, changes, charge, changed, and all is being stemmed with the last word which has been sorted out, which has been removed with this word called as CHANG. Whereas in lemmatization, you have a whole base word called as change. CHANG. So change, the lemmatized word is more good enough than the stemming word. Similarly, even in this example, you have better, best, good, and all. So for that, the stemmatized words are here bet, whereas the lemmatized word is good, which is a good. Good is the root base form for the word called as better, better, best, better, good, performance, and all. Maybe, of course, this is not true. So when we are doing the text pre-processing, in order to make our model ready enough, we should also ensure that the words, the sentences, the phrases are stemmed and lemmatized properly. Okay, see in this, now if we apply for our input, what is our input statement? Today we are discussing for this input statement, if we try to lemmatize, now this we are discussing. Of course, V and R have gone removed in the stop word removal. Even the about has got removed in the stop word removal. In has removed. So from this, discussing has been stemmed out in the form of in lemmatize as discussed. Introduction, knowledge, sharing session. Whereas in stemming, if we could see, the word discussing has become, of course, the discuss only. Whereas introduction has become introduct. Please have a difference here. In stemming, I repeat the point. The word introduction has been paraphrased to introduct in stemming. Whereas in the lemmatization, it is retaining the same root base form. Here, knowledge sharing session, it has been converted or stemmed out to share in the stemming text. Whereas in the lemmatized, it is just a sharing. So this retains the good base form for the inputs. So till now we have seen stemming, we have seen lemmatization, we have seen normalization, and we have seen the stop word removal. Putting it all together, this is how our input sentence. What was my input raw sentence? This is how, with double quotations, with comma, with capitals and all. After normalizing, it became free from commas, full stops and all. After tokenizing, this is how the words are being listed. With removing the stop words, now this is how it is a final thing. With the lemmatization, that's what I have mentioned, which is a more good form when compared to stemming. For some words, there may not be more difference between stemming and lemmatization, but based on here we could see discussing, even in lemmatized it has become the word discuss, even in stemming we have retained the same thing. But for these words, there was a much difference in stemming and when compared to lemmatization. So in this today's session, we have seen the basic steps to perform NLP, pre-processing, next the approaches. I have also got one more example which I have run in the Colab, where we can we can just import some NLTK and next download some punctuation, stop word and word name. We can directly import and download it from the Python or from the Jupyter or any Colab. Next, I have given the input sentence today. We will be discussing in detail about NLP basic steps in text pre-process. This is my given text followed by full stop, followed by comma and all. So for this is how I have just rendered as a summarized in one Python file. We could see that the normalized text is like this. Please have a look. In the normalized text, it is all being removed from the special characters and which is in the small case form. If you could see in the tokenization, we have to import porter stemmer, which as I have stored, and also we need to take from the lemmatizer. These two are the standard functions to perform libraries which are to be imported to perform stemming. Even we can also import stop words and also tokenize. So if we could see after tokenizing and all, this is how the text output looks like after stop word removal. Today, yes, discussing detail. NLP is one token, basic is one token, steps, text and pre-processing. Got it? And now when we come, this is all the stemmed words away from ing form and all. Today, discuss. Discussing has become now discuss in detail about and basic steps. Steps, if you could see, my initial was steps. Now in the stemming, it has become step. In text pre-processing, this was my actually entered or the given word called as pre-processing. After the stemmed, it has become now pre-process. Now if we could see in lemmatized, this is how we have today discussing. See, we could see the difference between the lemmatization and stemming. Here NLP basic steps, of course text, and here it has been retained the same original form of what we have given here is this one. So it has retained to this only, this one only has got retained it as pre-processing only. So this is how we have seen in today's session about how to perform the basic pre-process. Also we have Unicode conversion, we have some other operations to perform, but stemming, tokenization, I repeat the point, stemming, tokenization, yes, stop word removal, lemmatization, normalization are the basic steps that are mandatory for us to ensure that our input text becomes into a normal and to a standard form ready enough to perform of our NLP pipeline activity or NLP model to be run. Okay. In the next session, we'll be seeing about the NLP pipeline activity. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.